Hi children, today we'll talk about simplification of fractions. First of all, we'll focus on where simplification came from, and to understand the meaning, we'll work on models for this. So let's start working on the models first. As you see in the figure, the circles have equal size. You can see that the circle on the left side of the equation is divided into 12 equal pieces, and 10 of them are painted. Please count. Did you see? Yes. Okay, now let's continue to speak. It's understood that the circle on the right side is divided into 6 equal pieces and 5 of them are painted. Did you check it? Okay, yes. When you look carefully, you may see that the painted areas have the same size in both circles. Did you see? Yes. We can say from here that the fractions to be written to represent the painted regions in both circles must be equivalent to each other. Now, as you see in the figure, on the left side of the equation, we have a circle, and written here its fraction form. We know from our previous lessons how we may write its fraction form. Firstly, this is my whole, and divided into 12 equal pieces in total. So I should write the denominator as 12. What about numerator? The number of shaded regions. Shaded regions should be written here. 10 pieces are painted here, so I should write 10 as the numerator of this fraction. Now let's come to the second figure. This circle is also have the same size with this circle, but this circle is divided into 6 equal pieces, and only 5 of them are colored. 5 of them. Now here 10 of them, as you see. As you see, the colored regions, the amount of colored regions are equal to each other for both circles. Now let's write the fraction form of the circle on the right side of the equation. In total, it's divided into 6 equal pieces. So the denominator of the fraction should be 6. And what about the number of shaded regions? I should write the number of shaded regions on as the numerator of this fraction. 1, 2, 3, 4, 5. So I should write here 5. And the shaded region, the amount of shaded regions for both circles are equal to each other. We told. That's why we put between these two circles an equal sign. And because of this fact, these two fractions should be equivalent to each other. Now, if you look carefully on the right side of the equality, we have fraction here, 10 and 12. And 5 is the numerator of the second fraction, and 5 is the half of 10. 6 is the denominator of the second fraction on the right side of the equation, and 6 is also the half of the denominator of the first fraction, half of 12. So I reached 5 over 6 by dividing both numerator and denominator of the first fraction with 2. So if you divide 10 with 2, you will get 5. And if you divide 12 with 2, you will get 6. So what is 2? What's the meaning of 2? As you see here, 5 and 6 are consecutive numbers, and there is no common divisor other than 1 for them. And what about 2? 2 is the highest common factor of 10 and 12 here. And we divided 10 and 12 with their highest common factor, 2. And we get a result 5 over 6, another fraction. And can you divide 5 and 6 with another number other than 1? No. So 5 over 6 is the simplest form of 10 over 12. This is another terminology on fractions, simplification. 5 over 6 is the simplest form of 10 over 12. So how can you reach the simplest form of any fraction? Come to the result. You should divide both numerator and denominator of the given fraction with their greatest common divisor or highest common factor. Did you understand the subject? How you may simplify a fraction and how you may write it in its simplest form? So, okay, well, now let's come to the second example and go a bit faster than the first one. There is an equal sign here between these two figures. They are equivalent rectangles, and the rectangle on the left side of the equation is divided into 15 equal parts, equal pieces, and only 5 of them colored. So what is its fraction form? 15 is the number of all pieces, so I should write here 15 as denominator of the fraction. And how many of them are colored? 5. 5 should be the numerator of the fraction. What about the second one? As you see in the second one, the shaded region is only one piece, but the amount of this shaded region on the second picture is equal to the amount of shaded region in the first picture. And write the fraction form of this shaded region for the second picture, or on the right side of the equation. It's on the right side of the equation. 1, 2, 3. The whole is divided into 3 equal parts. So I should write 3 as the denominator of the fraction, and only one of them is colored, as you see here. So I should write 1 as the numerator of this figure, 1 over 3. And 1 and 3 cannot be divisible by with a number greater than 1. So 1 over 3 is in its simplest form. What about 5 and 15? They should be equal to each other. There is an equality here. They should be equal to each other, because we may say from this picture. The reason comes from this picture. Figures are equal to each other, and shaded regions are equal to each other. So if you write for both shapes their fractions form, they should be equal to each other. Now let's continue with the simplification of 5 over 15. What is the highest common factor of 5 and 15? Of course, you may tell easily it's 5. If you divide the numerator with 5, you will get 1. If you divide the denominator with 5, you will get 3. So if you face with a fraction, any fraction, please try to write it in its simplest form by dividing with the highest common factor of numerator and denominator of the fraction. Now, I think you understood very well by looking these two examples. Let's continue with the next page. Simplifying proper improper mixed fractions by using highest common factor. Of course, highest common factor is the main subject here to simplify any fraction. Reduce or simplify each proper fraction to its lowest term. I think you are learning the terminology again. Reduce, it means simplify. Its lowest term, its simplest term. Okay, simplest, lowest, simplest. Reduce, simplify. Now, in the first example, 3 over 6. What is the highest common factor of 3 and 6? Of course, 3. If you divide both with 3, you will get, if you divide 3 with 3, you will get 1. If you divide 6 with 3, you will get 2. 1 over 2 is its lowest term. And the second question, try to find the highest common factor of 32 and 56. In a place, you may use in another place 32 and 56. Divide with 2, 16. 28. Continue to divide with 2 again. Both are divisible by with 2 because of the continue. Say 8 and 14. Continue with 2 again. 4 and 7. 4 and 7 have no common divisor greater than 1. So 2 times 2 times 2 is 8. If you divide both numerator and denominator with 8, you will get on the numerator 32 over 8 is 4. 56 over 8 is 7. You will get 4 and 7, 4 over 7. And you may write from here also. This is for numerator, this is for denominator. Now let's continue with the third one. 30 over 48. Can you find the greatest common divisor or highest common factor of them? Now, you may continue like this. If you have any common divisor greater than 1, you may continue with dividing with this number. 2, for example, is common divisor for these two numbers. If you divide these two numbers with 2, you will get for 30, 15. And what is the result if you divide 48 with 2, 24. Now, is there any common divisor of 15 and 24 greater than 1? Yes, 3, for example. If you divide with 3, 15, you will get 5. If you divide 24 with 3, you will get 8. That's all. You applied 2 steps here to reach the simplest form of 30 over 48. But you may find in another place, in a free place, their greatest common factor or highest common factor to reach the result in one step. What about 9 and 81? we know 9 times 9 is 81. So the greatest common factor or highest common factor of 9 and 81 is 9. If you divide 9 with 9, you will get 1. If you divide 81 with 9, you will get 9. So 1 over 9 is the result, is the simplest form, is the lowest form of 9 over 81. Okay, so we'll use always the highest common factor to make simplification on fractions. Reduce each improper fraction to its lowest term. We know the meaning of this question now. Please don't forget it. Okay. Now 24 over 15. They both divisible with 3. If you divide with 3, you will get 8 for 24, and for 15 you will get 5. 8 and 5 have no common factor or no common divisor greater than 1. So 8 over 5 is the simplest form of this fraction. What about 8 and 6? 8 over 6. If you divide with 2, you will get 4 for 8. And if you divide with 2, you will get 3 for 6. So 4 over 3 is the simplest form of this fraction. Now let's continue with the next one. 35 and 45. If you divide with 5 for 45, you will get 9, and for 35 you will get 7. 9 and 7 have no common divisor other greater than 1. So 9 over 7 is the simplest form of this given fraction. What about 56 and 32? If you divide with 4, you will get 14 for 56 and 8 for 32. What about 14 and 8? Yes, you may divide them 2 with 2 again. If you divide both with 2, you will get 7 for 14 and 4 for 8. That's all. 7 and 4 have no common divisor greater than 1. 7 over 4 is the simplest or lowest form of 56 over 32. Now reduce each mixed number to its lowest term. Here, reducing or simplifying only the fraction part is enough. Write here 10 again and simplify 8 and 32. 32 and 8 both are divisible with 8. 8 over 8 is 1. 32 over 8 is 4. This is the simplest form or the lowest form of the given fraction. And 2 right here, the whole part, whole number of the mixed number. 2 and 4 only make if you have a mixed number. Please make the simplification for only its fraction part. 2 and 4 are divisible with 2. So 2 over 2 is 1, 4 over 2 is 2. So this is the simplest form of the given fraction. 7 and 12 over 24. They are divisible with 12. 12 over 12 is 1. 24 over 12 is 2. So the result is the simplest form. 12 and what about 4 over 28? 4 and 28 are both divisible with 4. 4 over 4 is 1. 28 over 4 is 7. I think I am a bit fast, but you should know division, multiplication, all multiplication tables. Children, please work hard. Yes. Now there are there are some fractions. I should remark the fractions which are in their simplest form. 2 over 3 is in its simplest form because between 2 and 3 there is no common divisor greater than 1. 5 over 10, I should simplify with 5. If you divide numerator and denominator with 5, you will get 1 for numerator and 2 for 10 for denominator. 7 over 2 is in its simplest form. And 4 over 6, both are divisible with 2. If you divide both of them with 2, you will get 2 for numerator and 3 with denominator. 11 over 5, 11 and 5 are prime numbers, so they have only common divisor 1. So it's in its simplest form. What about 3 over 7? 3 and 7 are also prime numbers, so they are in their simplest form. 1 over 4, of course, it's in simplest form. 32 over 12. Divisible, they are divisible, they means here numerator and denominator. Divisible with 4. If you divide with 4, 32 will be 8. And this is 3. 12 will be 3. So 8 over 3 is its simplest form. 10 and 9. 10 and 9 are consecutive numbers. So they are 10 over 9 is in its simplest form. 14 and 11. They have no common factor or divisor greater than 1. So this fraction is also in its simplest form. 9 over 21. Both are divisible with 3. If you divide with 3, you will get 3 as the numerator. And if you divide 21 with 3, you will get 7. So 3 over 7 is its simplest form. What about 6 and 17? They have no common divisor greater than 1. So 6 over 17 is also in its simplest form. The numbers I remarked here are sketching a circle like circle are the fractions which are in their simplest form. Yes, I think you learned very well the simplification of fractions. If you face a fraction in your life, please write it's in its simplest form. This is our main subject, main problem. This is our first job. Write a fraction in its simplest form. Writing the fraction in its simplest form. This is our homework. Now today's lesson is over. Hope to see you soon. Hope to see you on the next lesson. Bye.